Hello everyone and welcome to my channel. In this tutorial, we'll explore how to build a simple graphical user interface calculator using Python and Tkinter. If you're watching this tutorial, you probably already know how to make a calculator program in Python, and now you want to learn how to build a graphical user interface for such a program, so it's more presentable and easily reusable. Throughout this tutorial, we'll be working with Tkinter, which is the standard GUI library for Python. If you're interested in learning more about the library and its functionality, the link to the detailed guide is available below the video. Before we dive into the code, let's first discuss what type of calculator we're going to build, its functionality, and its must-haves. The graphical user interface we will be building will look like this. The following features should be considered as must-haves for this app. Number 1. It must have an equation line on the screen to display the mathematical equation and the result. Number 2. It must have buttons which must represent numerical values or mathematical operations and be clickable. Number 3. It must have the mathematical operations functionality, such as addition, subtraction, multiplication, and division. And number 4. It must perform mathematical calculations and return the result when we press the equal sign, as well as clear the equation line when we press C. In this section, we will build the graphical user interface main screen for calculator in Python. As the first step, we're going to import the required dependency. Next, we will define a calculator class and add the init method and the execution statement. This will be our main frame on top of which we will be building the graphical user interface and calculator functionality. This method is specific to Python classes and acts as a constructor in object-oriented concepts. This method is called right away when an object is created and allows it to initialize its attributes. Next, we will pass two arguments into the init method, self and master. Self represents the instance of the class, which basically means that the init method is a method of the calculator class. Master is a local variable that we pass into the init method, and what it does is it creates a top-level widget, which is the main window of an application. More details about it will be discussed further. Next, we will create a reference to the main window of the application within the calculator class. Then we will add a title to our application. And let's call our program Python Calculator. Next, let's add the standard execution starter. Here we'll have to define a local variable root and assign tk to it. Tk is a Tkinter class which creates the main application window. Now let's define another local variable, my_GUI, and assign calculator class to it while passing root as an argument into it. Essentially, this step creates a GUI by telling a class to use root, which is tk, as its main window. And finally, add root.mainLoop, where mainLoop is a method of tk, basically telling the app to wait for events such as clicks and update the UI accordingly. This was a lot of information to consume at once, but we have completed the first part of the tutorial and now we can actually see our initial screen. Let's run the code and see what we get. We see the initial gray screen of our application created. In this section, we'll add the equation line to the graphical user interface main screen. As the next step, we would like to add an equation line to our calculator graphical user interface, which is the same thing as the display on a regular calculator where all of the operations are shown. This part is very intuitive and requires us to add only 2 lines of code to the init method. The reason we're adding it to the init method is because we want this to be created as soon as the application starts. So let's discuss it step by step. First, we will create a line where we display the equation. We need to create some equation line that we want to add to our calculator class. Hence, we define it as self-equation and then use a Tkinter class entry to create a widget. There are a few arguments that go into the entry class. We need to let it know that it should belong to our master window, as well as some basic styling properties such as width and border. I selected 36 for width and 5 for border width. Feel free to change these, but for now, please follow with the values I have assigned. Next, we will assign a position for the equation line in the main application window. So far we have created the equation line which belongs to the calculator class, but it doesn't know yet where on the main screen it should be positioned, and we will place it at the top of the graphical user interface. To do this, we will use the grid method of the entry class along with some parameters. Now, what goes into grid method needs a little explanation. The first parameter is row. Recall that Python indexing starts with 0, so the first row has an index of 0 and the first column has the index of 0 as well. Since we're placing the equation line at the top of the graphical user interface, its row should be 0. The column span will specify how many columns will this line occupy. Let's take a look at the final image of the calculator app. You will notice that the app buttons are placed into 4 columns. And since our equation line takes up the whole width of the screen, it means that it takes place of exactly 4 columns. This is also why we use the width of 36, since it can be divided by 4 without the remainder and keeps the layout unaffected. The pad X and pad Y are the basic paddings that are added to the top, bottom, left, and right of the equation line, just to visually give it a little more space. Now let's run the code and see what we get. Notice that the application window actually became smaller, since now it is wrapped around the equation line. You can also freely type anything you want inside of the line just to test its entry properties. And as you can see, no operations will take place because we haven't added that functionality to the app just yet. In this section, we'll create the buttons for the calculator in Python. We have created the calculator main screen and the equation line attached to it. The next step is to create the buttons for this graphical user interface so it can work like an actual calculator. This is the most tedious part of the code and technically a little more advanced than the previous sections. Let's go through all of the code in detail. First, we're going to create a new method, createButton. Next, we'll create the button objects. You will notice that all of the buttons follow the same template. It is a tedious process to create each button one by one, and it can be automated using a loop. For the purposes of explaining this step in detail, each button will be hard-coded. Essentially, each button name represents the action we want this button to take. For example, B1 is a button for digit 1. Now, the question that comes up is, what is this addButton method? It is another method that we will define later in the code. What it will do is it will create the button object we need with the value we need. It will be explained in the next section. The logic here is that for each button inside the createButton method, we call the addButton method in order to create the button and add it to the main screen of the application. Now let's add the remaining buttons. Next, we will arrange the buttons into rows in which they appear on the calculator. What we want is to have 4 rows with 4 buttons in each row, so they can appear in the same order as they are in the actual calculator application. Next, we will populate each row of the calculator main screen with the buttons. As the final step of adding buttons, we will loop through every column of every row and populate it with the button. One thing to keep in mind is that we're starting from row index 1 to 4, since our row index 0 is already populated with the equation line, and our columns will be indexed from 0 to 3. As an additional step, after we have created this method to create the buttons, we need to call it from our init method by adding self.createButton to it. Note that if you try to run the code now, you should get an error. The reason for the error is that we used the addButton method inside of our createButton method, but we haven't defined it yet. We're going to cover this in the next section. In this section, we will work on adding the created buttons to the graphical user interface. Remember the addButton method we used to create each button? This is exactly what we will focus on adding now. This method creates and returns a Tkinter button object that we will then add to the graphical user interface. First, let's define a new method, addButton. We will pass two arguments into it, self and value. Self assigns this method to the instance of the calculator class, and value is the actual value that we want to display on each of the buttons in our graphical user interface. Next, we will create a button class with a few parameters that we need. Here, self_master parameter assigns the button object to the calculator class. The text parameter takes the value we passed as an argument, which will be displayed on the button. The width parameter is set to 9, which is just the styling for our buttons, so we can adjust the width of each button. Recall that the width of the entire application is 36, and we have 4 buttons, meaning that for us not to have any leftover space, we will set the width of each button to 9. Now let's run the code and see what we get. It is a full-built graphical user interface with clickable buttons. It works like a regular calculator app now, except nothing happens when the buttons are clicked. In the next section, we will assign actions to each button of the calculator app. The last step is to add the actual mathematical functionality to the calculator app. Let's define a new method, clickButton. We will pass two arguments into it, self and value. Self assigns this method to the instance of the calculator class, and value is the actual value that we would like to use on each click of the button in our calculator application. In order for the calculator to know what to do next, it needs to know what is displayed in the equation line. In order to get the content from the equation line, we will use the get method of the Tkinter entry class, which represents our equation line. This means that if, for example, we have 1 plus 1 in the equation line, this function will take this line and store it as a string in the local variable current equation. Next, we will start adding logic to the clicks of each button. And the simplest one to do is what should be the action performed by the calculator when the user clicks C. We would want the equation line cleared if a user clicks C, and this is exactly what we do by using the delete method of the entry class, which represents the equation line. The second part of the conditioning is to add the action performed by the calculator when the user clicks the equal sign. What we want to do is compute the answer and display it in the equation line. It will include a few steps. It will include a few steps. First thing we do inside the elif part is compute the current equation, which we already have from step 1. We use the Python eval method, which parses the string expression and evaluates it. For example, if your current equation is 1 plus 1 and it is a string, if you run 1 plus 1 in Python, it will give you 2 as output. This is exactly what the eval method does here. Next, we will delete the current text from the equation line using the delete method of a Tkinter entry class, so we can insert and display the answer. And finally, we will insert the answer into the equation line using insert method of a Tkinter entry class. And the last step in the conditioning is to add what we can call a catch-all condition that we put in the else part. Essentially, if a user is clicking anything else but clear or equal sign, it means that they are clicking on a digit from 0 to 9 or a mathematical operation, which is addition, subtraction, multiplication, or division. All we want to do in that case is to add it to the equation line. First, we will delete the text in the equation line. Then we will concatenate the current equation with the value which comes from the recent click and insert it into the equation line. The last step we need to do is to let our buttons know what actions should be performed when each of the buttons are clicked. To do that, we need to go back to our addButton method and add one more parameter to the button object creation. What we need to add is a command parameter. A command is a parameter for the button to let it know what action should be performed when the button is clicked. In our case, what each button should do is what is defined in the clickButton method. Now let's run the code and see what we get. Now let's test our calculator. Perfect. What you can see is a perfectly functioning calculator app with a graphical user interface. In this tutorial, we explored how to build a basic graphical user interface calculator using Python and Tkinter. Feel free to leave comments below if you have any questions. Please like and share the video, subscribe to the channel, and stay tuned for more of my Python programming tutorials.